So the first thing we'll cover today are going to be the product and quotient rules. Actually, I'll start with the product rule, okay? This will be, oops. This is chapter 3 point something, which will be the product rule and the quotient rule. Okay, so we'll start with the product rule, and things are going to make a lot of sense, all right? Yeah, product rule. Okay, so what we're looking at is ddx, or the derivative of whatever I'm about to write in terms of x. Again, many different ways to write this, of f of x times g of x, where f and g are both functions of x, is going to equal f prime x times g of x plus f of x times g prime of x. You might see me write this as f prime g plus g prime f. I like to write the primes first so I don't forget which one I've already primed, and I just kind of rotate through. You might see me write this as a prime b plus b prime a, where a and b are just functions of x in the same way f and g are. It's all the same thing. That's it. That is literally it. Okay. So for example, let's say you have f of x is equal to 5x to the fourth plus 73 times x to the 17th minus 28. Okay. I'm going to call this, I'll color code it actually. I'm going to call this f, and I'm going to call this g. Okay. So what are our two parts? Or four parts actually. We need f prime, normal f, g, and g prime, right? So what I'm going to do is write the parts out. F of x, or you can just write it as f, that's fine too, is going to equal 5x to the fourth plus 73. And we also need f prime, which is going to equal the derivative of this guy, which is going to be 20x to the third plus 0, which you can just write as 20x to the third. Okay. And then I'm going to write g of x. G is equal to x to the 17th minus 28. And that means g prime is equal to 17x to the 16th. Right. And if we go back, I realize that it's a little bit confusing to call this function f. So if you want to just call this like h or literally just some other function, it's fine. Okay, it is literally all fine. All right. Okay. Again, this f, as in the whole function, is different from like a sub-function, if you will. Okay. So you know the derivative of f times g is going to be f prime times g plus g prime times f, like that. Yep. Okay. So just put the moving parts in. Again, if we call that function h, if we call this whole thing h, right, then you know that h prime of x is going to equal, what's f prime? F prime is 20x to the third. And you're going to multiply it by the whole g, not just part of g, the whole g. So x to the 17th minus 28, right? Parentheses are important because if you don't put them in, what you're going to tell me is it's just multiplying this to here. And that is wrong. I will not give you credit, okay? Parentheses, my friends. And then you're going to add it to g prime times f. So g prime is 17x to the 16th times, what is f? f is the whole thing of 5x to the fourth plus 73, x to the fourth plus 73. That's it. That's the quotient or the product rule, my friends. Okay. There are more examples on the notes. Please do them. But I'll work out a couple more just for you. Okay, just for you. Let's say I have h of x is equal to 7x to the third plus 17x. Sure, you could distribute, right? You could do that. You could do the constant multiple situation, but I'll tell you, we could product rule this too. All right, we're going to call f is equal to 7, right? Because they're being multiplied, which means f prime is going to equal, what's the derivative of a constant? What's the derivative of 7? It's going to be 0, 0. Trust and believe. And then you're going to have g of x, which is equal to x to the third plus 17x. And you're going to have g prime, which is going to equal 3x squared plus 17. And then you're going to say, oh yeah, I know how this works. H prime of x, or you can just shorten it as h prime because we're only working in one variable. It's fine. Is going to equal, to be very clear, you can only write it as like h prime or y prime or whatever when you're working in one variable. Okay. The moment you start working with multiple variables, you gotta be very clear what you're priming and what you're not priming. Okay. Anyway, so this is going to be f prime g. So it's going to be 0 times x cubed plus 17x plus g prime, which is going to be 3x squared plus 17. Oops, that's a bad 17. 17 times f. And that is going to be 7 times 3x squared plus 17. And if you notice, this is just the constant multiple rule. Okay, nothing crazy here. Okay, now what I'm going to do is I'm going to have you product rule this next function, which is going to be x plus 9 squared. If you notice, you can chain rule it. What I want you to do is product it first and then chain. Okay, product first, then chain, so you can check your work. Okay, hit pause and then come back and I'll just solve it up for you. Okay, so if I were to solve this out, I would actually write this as x plus 9 times x plus 9, so it looks like a product, right? F and g, right? F is going to be x plus 9, g is going to be x plus 9, which means the derivative of f, which is f prime, is going to be 1. Right, because the derivative of 9 is 0, the derivative of 1x to the first is 1. It's easy enough. And the derivative of g, or g is x plus 9, sorry. And the derivative of g, which is g prime, is also going to be 1 because these are the same. But that's okay, right? And then you put it into a product rule situation. That gives you h prime is equal to f prime g. So f prime g is 1 times x plus 9 plus g prime f, which is going to give you 1 times x plus 9, which is going to give you 2x plus 9, which if you chain rule it, you bring the 2 down, you subtract 1, you leave the inside alone, you multiply by 1 on the outside. That's going to give you 2x plus 9 times 1, and it works out. Or if you want to be pedantic, you can also technically FOIL it. Would I recommend it? For this one, I mean, yeah, I don't care. It's easy enough, but I'm going to give you harder ones so you can't FOIL it. Okay, but if you were to FOIL it, you know that h of x is going to equal x squared plus 18x plus 81, which means h prime is going to equal 2x plus 18, which if you factor it, gives you 2x plus 9, which equals. Okay. Many, many different ways to do these problems. One more problem I'm going to show you is problem number 4, which says h of x is equal to 2x plus 9, 3x plus 6, and x minus 1. And I want you to product rule this. Okay? Figure out how you want to write your products, and then we'll come back. Okay. So hint number 1, I'm going to call this f, and I'm going to call this whole thing g. Okay? And again, feel free to pause this as you work it out. I'm going to slowly work this problem out for you. So 2x plus 9, which of course means that f prime is equal to 2. Nothing crazy here. And then g is going to equal 3x plus 6 and x minus 1. Can you FOIL this? Yes. Do I recommend it? Again, for this specific problem, you totally could. But I'm going to gently suggest you don't. Okay? Because I will give you harder problems that you can't do that too. Okay. If you were to derive this, right, what rule would you use? You might notice that this is another product rule living in here. Okay? So we're going to use another product rule on this. Okay? We're going to call this A, and we're going to call this B. Okay? Since this is also a product, right, you know that you can write G prime as equal to, oh, well, the derivative of A times B, right? Some function of A times some function B, right? Which is going to give you A prime B plus B prime A. These are primes, okay, friends? Not to the first, prime. Okay. Like I said, this is a nested product rule, right? So if you have A is equal to 3x plus 6, then you know that A prime is going to be 3, right? You know B is equal to x minus 1, then you know B prime is equal to 1, which means, I'm going to shimmy this over a little bit so we have some space, which means you can actually just plug this right back into here, right? And this is going to equal A prime, which is 3, times B, which is x minus 1, the whole thing, plus B prime, which is 1, times A, 3x plus 6. Now you know what F is. F prime is G prime, right? So now what I'll say is, that means H prime is equal to F prime times normal G. So it's going to be 2 times 3x plus 6, x minus 1, plus G prime A. G prime is this guy in parentheses, right? This guy in parentheses. So it'll look like 3 times x minus 1 plus 1 times 3x plus 6 g prime. You want to multiply it by f, which is going to be 2x plus 9. You can just leave it like that. But interesting idea. What if you distribute? And I don't mean like completely FOIL it out, just distribute this into this term and this into this term. Okay? What you'll get is you get nothing changes here, of course, right? You get 2, 3x plus 6, x minus 1, plus 2x plus 9 times 3 times x minus 1 plus 1 times 3x plus 6. I'm going to shimmy so we have some space. Times 2x plus 9. Interesting. I'm going to do a little bit more color coding, okay? So we know that this is going to be f prime, right? And we know that this purple is going to be b and b prime, right? This is going to be f prime. This is going to be normal f. And this is going to be normal f, right? Oh, but that also means that this is going to be b. Do you see where this is going? And then you're like, oh, wait, this piece is a, right? And this piece is a prime. And this piece is a, which means you can actually kind of just write this as like if h of x is equal to f times a times b, right? And you get h prime is equal to f prime a times b, right? That first piece. Plus f, normal f, right? Times a prime times, oh look, normal b plus, actually it doesn't matter if the plus is green or not. I'll do in white though. Plus, oh look, this is all multiplication, right? This is like b prime times a times f. We can reorganize it, right? We can reorganize that as normal f times normal a times b prime. I'm just going to leave that there for you, and you're going to think about it, okay? I'm going to leave that there for you, and you're going to think about it. In particular, I'm going to ask you, base off of this, let h of x be g sub 1 of x, right? Again, just some function g1 times g2 of x times g3 of x times some amount of them, right? What is h prime of x equal to? Okay. All right, good. So now my next question is, what happens when, oops, I was not supposed to do that, when you have h of x is equal to 1 over x plus 3. And my hint for you is turn it into a product first and then derive. Okay. So I'm gonna give you guys a second and then, we'll loop back. To write h of x as a product, you can write it as 1 times x plus 3 to the negative 1, right? Because like this is going to be x plus 3 to the negative 1, and you can always put like a 1 out front, right? Okay. Well, now that you have it as a product, could you product rule it? And if you can, there's a second rule you need. What would it be? I'm going to give you guys a second to identify it, and then we'll kind of work it out. Okay. So I would argue that f of x is going to be 1, right? Just that first piece. And g is going to be x plus 3 to the negative 1, right? F prime is going to equal 0. That's pretty straightforward. What about g prime? I'm going to give you guys a second to do it. Please hit pause, and we'll work it out together. I would say if we were to ignore this, right, just cover this up. Don't even bother looking at it. If we just imagine this is what we're working with, I'd say this is a chain rule. This chain rule says you bring this negative 1 out front, you leave the stuff on the inside alone, you subtract 1 on top. What is the inside? It's x plus 3. And then you want the derivative of the inside. The derivative of x plus 3 is 1, right? And you can just write this as negative 1 x plus 3 to the negative 2, which can be written as negative 1 over x plus 3 squared. Wayman, hear me out. At this point, you can just put it into our product rule now, huh? Because then if you do that, you'll have h prime is equal to f times g prime, which is going to be negative 1 over x plus 3 squared, plus f prime times normal g, which you can either write it like this or you can write it as 1 over x plus 3 at this point. Okay. I like leaving it like this because it's easier to handle. It's up to you. 1 over x plus 3 doesn't really matter because this becomes 0, right? Because 0 times anything is 0. And that is going to return negative 1 over x plus 3 squared. Cool. You can product rule on fractions because you know you turn into product and call it a day. Okay. So let's say I give you problem number 2. What if I give you h of x is equal to 3 over x plus 7, right? I'm going to give you a second to do it. Hit pause, come back, I'll tell you what the answer is. Again, process is the same. Okay. If you were to do out, and I won't do this one out for you, I'm going to have you figure it out how I got this answer to begin with. It's going to be x plus 7 times 0 minus 1 all over x plus 7 squared, which should give you negative 3 over x plus 7 squared. Okay? Yeah. Okay. Let's say I give you another one. Let's say I give you x, let's call it h of x is equal to x over x plus 2, right? Again, kind of a rinse and repeat kind of deal. F is equal to x, f prime is equal to 1, g is equal to x plus 2 to the negative 1, g prime is equal to negative 1, x plus 2 to the negative 2 times 1, which should equal negative 1 over x plus 2 squared, right? And then you just plug it back in. H prime of x is equal to f times g prime, which is going to be x times negative 1 over x plus 2 squared, plus f prime times g, which is going to be 1 over x plus 2, right? simplify that, which gives you negative x over x plus 2 squared plus 1 over x plus 2, right? Combine like terms by giving it a common denominator. It's going to be negative x plus 2 all over x plus 2 squared, which should give you 2 over x plus 2 squared. And so my next question for you is, what if I give you h of x is equal to the sum f of x divided by some other g of x? Right. I'll give you a second to think about it. Please hit pause. We'll work it out. Okay. All right. If you're coming back, I assume you've done it. This can be written as f of x times g of x to the negative 1. Right. Okay. Well, if we follow just like normal product rule stuff, right, then you get h prime of x is going to equal to this f of x times the derivative of this whole thing, right? And it's a chain rule. So we're going to chain this down. This gives you, you know what, let me color code. Let me color code it for you. Put f of x here. You put g of x here. F prime, which is going to be an orange. F prime of x times normal g of x, this normal bit, plus normal this times the derivative of this. Again, it's a chain rule, right? Just a chain rule. And to chain rule that, you multiply this down, so that gives you negative 1 times normal g of x, and then again, chain rule situation here, minus 2 times, and don't forget the inside. So again, right, this comes down here, which looks like that. Subtract 1 from here, which looks like that. Leave the inside alone, which looks like that. And then times the derivative of the inside, who cares what that is, times g prime of x. Just like that, right? But that means we can simplify this into f prime, and I'm going to stop writing the of x business just because it's a lot, all over g of x plus f times g prime of x times negative 1. How did I do this? I organized this here, I organized that here, and I moved this here. That's all, okay? No crazy business. All over what? All over g of x squared. Right. I guess you could erase that too. Okay, let's reorganize it one more time, right? We want to combine like terms, and these almost have a common denominator, right? This is g to the first, this is g squared, right? Okay, that is okay, because then we can write this as, oh, this is the same as saying f prime times g, right? All over g squared, right? Because you multiply g on top and on the bottom, right? Oh, this right here makes the whole thing negative. So you can turn this into a minus sign. Minus f times g prime all over g squared. And then all of a sudden, you have f prime g minus f g prime. Again, this is all being multiplied all over g squared. And congratulations, you have discovered the quotient rule. Okay. You might see me read this as the derivative of a over b is equal to b times derivative a minus a times derivative b all over b squared. So you might hear me read this as BDA minus ADB all over B squared. It's all the same thing. This is how I remember it. I have a hard time remembering this. That's all. Okay. So, yep, that's it. That's the product and quotient rule for you. Um, yeah.